Okay, chapter 11. Review. Here it is. I would suggest it's probably the best type of review is if you pause, try the problem yourself, and then see what I do and see if you got it. Feel free to skip ones that you don't get. Anyway, I'll try to make sure I sort of pause for a second before I start a problem so you can pause your computer. Okay, so a question like this. Theta increases from pi over 2 to 3 pi over 2. What happens to the value of cos theta? So in the end, you really have two ways to think of this problem. You can go back to your good old unit circle, if you want, and think about the fact that pi over 2 to 3 pi over 2 really is this neck of the woods. And if you remember, cosine has to do with x values, and so when I'm up here at 90, my x value is 0, and then I go over here to negative 1, and then I come here and I go back to 0. So what's really happening then in this section is my value is decreasing from 0 to negative 1, and then increasing to 0. Now, before I leave the problem, I do want to remind you, though, that really what this chapter's been about is unrolling this guy out onto I'm not going to spend a lot of time making this perfect. Well, maybe I'll spend a little more time than that. Hold on a minute. It always works out better when you take the time to do it right. Okay, so here's 2 pi, here's pi over 2, here's 3 pi over 2, here's 1, here's negative 1, so I start here, I go here, then I go here, I'm here, and then I'm back up here. Just want to remind you about good old cosine when we roll it out, and that in the end this is quadrant 1, this is quadrant 2, this is quadrant 3, and a different color marker would be better. Quadrant 1, quadrant 2, quadrant 3, quadrant 4, and this question is really asking what the heck's happening in quadrants 2 and 3, and you can clearly see here it's going from 0 to negative 1 and then back up to 0. Okay, enough of that problem. Next one. What is the amplitude of the graph of y equals a sine b times x plus c plus d? You should know that format, by the way, of this particular graph. Amplitude. Amplitude basically is how far above and below the center line does this baby go. So I'm just going to go ahead and take a look at this and see how far apart they are. And I can do it by counting. 1, 2, 3, 4, 5, 6. So that means my center line for this guy really is 3 from either end of my lower high point, which gets me to arrive at my amplitude, which is 3. And remember, even like if this equation had an equation where it was like y equals negative 3 sine x, when you're asked for the amplitude, you're still going to say it's 3. Amplitude is always going to be really technically the absolute value of the thing in this position, because it's a measurement, it's a distance. Okay, moving right along. If f of x equals 2 sine 3x plus c, what is the maximum value of f of x? This is continuing on the same theme, really, and that is recognizing that this thing right here is my amplitude. So that's how far up and down this thing's going to go. And when I have this plus c, now oftentimes in the format we've written that we have this be a plus d, but you could put any variable you want. This is the thing that's going to move this baby up or down. So the maximum value then is going to be however much this thing gets moved up. Okay? So if this thing, say its center line starts up here, call this C, and then it does its thing, here's my A. So the maximum value of this thing is going to be C plus 2. I'm going to start from this center point and go up. Okay, next one. What is the frequency of the graph of the equation y equals 3 cos 4x? This is a fact that you must know, and that is the thing sitting here in the B position is the frequency. Now, by definition, what frequency really means is how many times it does its thing in 2 pi. That's what frequency means, as opposed to period. Remember, period is equal to 2 pi over b, which is the frequency, and the period is how long does it take to do its thing once. Okay, moving along. Number 5, I'm just going to use my little screen here to focus in on one problem at a time. A certain radio wave travels in a path represented by the equation y equals 5 sine 2x. What is the period? So this comes off of what I was just talking about. So remember, the thing in this position here we refer to as b, and the period is just 2 pi over b. So in this case the period is pi, which should make sense if you understand this, because b equals 2 is the frequency. Frequency once again means how many times does it do its thing in 2 pi. Well, it does it twice. This shouldn't surprise you because it only takes pi to do it once. So when I go through 2 pi, I get through 2 rounds of it. And you can always graph it also to look at it. Okay, number 6, phase shift. And this has a nice little twist that I think is important to understand. And I'm going to go back to sort of our standard form. So our standard form is f of x equals a sine b x plus c plus d. So notice that the phase shift, which is over here, is sitting in parentheses with an x. So when you look at this guy right here, it is not sitting there with an x. There's a 2 in front of it. So in order for me to line this baby up, I need to, and just to be complete about it, there would really be a 1 there. I need to get that 2 out. So I'm going to factor it out. So I have 2 times x plus. So now the question is really, what is pi divided by 3? Pi over 3 divided by 2, because I'm factoring it out. So either you can feel it, because if I take 2 times pi over 6, I get 2 over 6, which is a third. Or if you need to, because I know I need to factor out this 2, I'm really just taking pi over 3 and divided it by 2, which is pi over 3 times 1 over 2, which is pi over 6. And then plus pi over 2. Okay, but this problem is talking about the phase shift, and so when I see this plus pi over 6 here, and it's not a plus because this is a minus, so I take that back, this is a minus pi over 6. So that means that my phase shift is actually plus pi over 6, or to the right pi over 6. Okay, next problem. For y equals 23 sine 3/4 x plus 20 plus 18, which set of values represent all of the things we just discussed so far, more practice? Amplitude, period, vertical shift, and or phase displacement. And sometimes you'll see the words kind of this phase displacement. We've been calling it phase shift. It means the same thing. Okay, so let's start with the easy place. Hopefully we all like amplitude because it's pretty straightforward. It's sitting right there and I just grab it. Okay, the period. So, remember, this is the b, this 3/4, so the period then is going to be 2 pi over 3/4, which is equal to 2 pi, I'm just going to, over 1, times 4 over 3. So, it is 8 pi over 3. Next is the vertical shift, which vertical shift is usually pretty nice too, because it's pretty straightforward. So the vertical shift is just this plus 18. And then the phase displacement, or phase shift as we've been calling it, is found in the parentheses, and this time all as well, because there's just a lonely little x sitting there. So the phase displacement, since it's plus 20, is it's going to go left 20, negative 20. Okay. Write an equation for the sine curve whose period is 2 pi over 3 and whose amplitude is 4. So let's do that. Get rid of this now. So I'm just going to write my standard form out here, y equals a sine, and since I have no phase shift, I'll just go ahead and simplify the equation and just write y equals a sine bx, because that's really all I need. So y is equal to, my amplitude is 4 sine. Now this is where you got to be careful. I need to know what b is, and I don't know what b is, because b is frequency. I know what the period is. So if you recall, the period, which in this case is 2 pi over 3, and the period is equal to 2 pi over b. And so this one's nice because the numerators are the same, therefore the denominators are the same. Other ways that we do this is cross multiply. So in this case then b is equal to 3. And there you have it in all its glory. Okay, more. Number 9. And a lot of this is just kind of more and more practice just to kind of keep, hopefully, getting you in the zone of what we're supposed to know here. Amplitude. We love amplitude. There it is. It's a half. The period. Okay, so this is good practice because we're talking about, this time we want to know what the period is. So I'm going to actually drop right down here because I know what the frequency is because it's sitting right there. And I know to figure out the period is going to be 2 pi over the frequency, which happens to be 1/3. Now to clean this up, I'm going to go 2 pi over 1 times 3 over 1, which is 6 pi. Okay, number 10. In physics class, even notice the pattern shown in the accompanying diagram on an oscilloscope. Which equation best represents the pattern shown on this oscilloscope? So you'll notice that it's up to you. You get to decide what equation you'd like to write. That's not being directed. So I'm looking at this guy and I'm saying, well, something is going on here because this guy has a center line up here as opposed to where I normally see it down here. So I know then that this thing has been shifted up 1. So in just thinking about the blanks I need to possibly fill in, I know I need to fill in this plus 1 blank. Now, what else do I know that doesn't hurt too much? I can see right here what my amplitude is. And so my amplitude is 2. So y is equal to 2 sine. Now, I need to figure out my b, but before I do that, I want to talk about, is there phase shift? And I'm always rooting for there not to be, and in this case, there isn't, because the sine is just doing its thing. Remember, our kind of home base sine is one of these guys. So I don't have to worry about a c, I just need to figure out what b is. And the way I'm going to figure out what b is I'm going to look at this guy and say, how long does it take to do its thing once? And how long it takes is, if I'm walking along here looking up at it, I see that it gets the job done in 4 pi. So the period is equal to 4 pi. And I know that period is equal to 2 pi over b, and b is the thing that I need to get. So this is a case where if it's easier for you to see it, you can cross multiply. These pi's divide out, and so really all I got to do is divide by 4, and I see then that b is equal to 1/2. So I put a 1/2 here, x, and I am done. So y equals, I'll just clean it up, 2 sine 1/2 x plus 1. And I'm just going to use this as an opportunity to remind you, just put it in your calc and check to make sure. So if I hit sine 0.5x plus 1, and as I've said more times than you probably feel like hearing, I always like to start with a zoom trig just to get my calc in the zone of what I'm trying to do. And then in this particular case, my window is going from 0 to 4 pi. So from 0 to 4 pi. And I'm going to try to set this up exactly like what I see on my paper. I'm going to just let my tick marks do what they do. But I see that this thing is going from -2, and the y max value is 4. So now I'm going to hit graph, and I'm going to look at it, and I'm going to hope that it looks like what I see on my paper. And it does. The scale is a little bit different on this, but you can see that it is the correct... actually, because the reason this looks a little bit different is I set 4 pi to be my end here, and the graph itself, I'll bring it back up on the screen, is going a little beyond that. Over here, you'll notice that this thing, they've shown like a little bit of extra. Okay, that would be problem number 10, just so you know how far we're headed here. I believe that I do have 18 problems. Okay, number 11. Just get, whoops, didn't mean to do that. I'll get this out. The curve shown below is either sine or cosine. State the equation of the curve. So if I have a choice, and I can do either, I see this thing screaming sine, or I'm sorry, cosine to me, because I see my home base cosine curve doing its thing right here, which is quite lovely. So I'm going to go through the process of all the pieces that I need, and I can see that it's sitting right here on my x-axis, which makes me happy, and quickly I see that my amplitude is 2. So now I need to know what my period is, and I just see that it goes from 0 to 4 pi. So the period then is equal to 4 pi, and I know that period is equal to 2 pi over b, which gives me my b that I need for my equation. And so when I multiply it out, just to practice this a little more, the math will just show me the way here. And once again, similar to the last one, we find out that b is equal to a half. And in this case, there is no phase shift, so that's happy news, and this thing has no vertical shift either, so I am ready to piece this puzzle together. So I put in a 2 for my a cos 1/2 x. Now, just for practice though, I do want to talk about what if I wanted to write this as sine. So just to review, if I wanted to write this as sine, then I need to find one round of sine. So, and we usually want to kind of find that round that goes through the y-axis. So this guy is going to come out over here to give me my one round of home base sine. So you can see that for sine I am going to have a phase shift. Now just looking here, and I'm not going to worry about the scale right now, but this is pi, this is 2 pi, 3 pi, 4 pi. So that means when I come out here, I'm coming out to negative pi. So I'm going to put the pieces together over here to write this as sine. So a is still equal to 2. B is going to be the same. This period hasn't changed here, so b is equal to 1/2. But this time I have a phase shift. And so basically that phase shift is really just the opposite of whatever this starting point is, which in this case is negative pi. So c is equal to pi. So if I want to write this in terms of sine, I get 2 sine 1/2 x plus pi. And if you want to see this relationship that we've seen between sine and cosine, I need to actually distribute out this 1/2 f. 1/2 x plus pi over 2. Because if you recall, to go from sine to cosine, we just subtract pi over 2. And that's exactly what's happened here. When I take pi over 2 out of the picture, I'm left with 1/2 x. So there you go. Next problem. Just more practice. Once again, if you're in the zone, feel free to skip ahead. Also, though, I really suggest you stop the video and try on your own these various problems. Okay, so write both a sine and a cosine equation for the following. Okay, so where am I going to begin? I think I'm going to begin by seeing that something is going on here, because this thing's going from -1 to 1, 2, 3, 4, 5. So this thing has a vertical shift. So I'm going to just sort of get this in here first, because that is going to matter to me as far as taking a look at what's going on here, because it's not oriented to the x-axis. So I'm going to look here and say, well, do I see one round of sine? I'll start with sine. And so I am seeing one round of sine, and it is occurring right there. So I'm going to start going through the pieces of this puzzle. So I'll start with amplitude. So amplitude is, I can count 1, 2, 3 here. The amplitude is 3. The period, now notice, like, and these can come any old way they want to come. Notice that this is there's no pi's on this. It's just counting by whole numbers, 1, 2, 3, 4, 5. So this thing is taking 4 to get the job done. 1, 2, 3, 4. So the period then, in this case, is equal to 4. So then to get my b in this case, I'm going to say that the period, as we know, is equal to 2 pi over b. So we get 4b equals 2 pi. And I'm going to divide both of these guys by 4, and I get b is equal to, I'll reduce 2 over 4 to 1/2 pi over 2. So in this case, our b has a pi in it, which is fine. Okay, now phase shift. If I look at where this thing starts, this thing, as far as phase shift goes, is starting at -1. So my phase shift is going to be the opposite of -1. And then in this case, this one's a little fancier. Just to make it clearer here, I think I'm just going to make this my x-axis so you can see it. So this center line has moved up 2. So my d then is 2. So to put the pieces of this puzzle together, come over here. I get y is equal to 3 sine pi over 2 times x plus 1 for my phase shift, which I guess I didn't write that here, and then my vertical shift I have to put in a plus 2. Okay, I'm going to go ahead and distribute. So y equals 3 sine pi over 2x plus pi over 2 plus 2. And if I want to write this in cosine, this kind of is in a nice form, because really to get over to cosine, all I have to do is change this to cos and subtract pi over 2 once after I've done my distributing. So if I take pi over 2 away from this guy up here, I'm just left with pi over 2x plus 2. And I am not going to take the time right now in the video to do this, but I encourage you to always get your calc out and set the window to look like what you've been given, and sort of make sure that you've written an equation that looks like what you're trying to graph. Okay, the range of the function f of x equals sec x. Either you memorize these or you get it. There's a lot of options. I would suggest your calc really is a wonderful place to go here. But if you just remember, for one, and it just as like a quick thing to remember how sec is one of these guys, because there's a whole stretch that's not happening in here, because as I've talked about in class, sec is 1 over cos. And since cosine lives between -1 and 1, it's basically fractions. And when we flip fractions, they become bigger numbers. They're not fractions anymore, which is what this 1 and -1 is. So that's why there's an empty zone here. So to describe the range, then, the range for, remember range has to do with y, for secant goes from -infinity, I'm putting a parenthesis, up to -1. I'm closing that because -1 is in it. Union from 1 to infinity. Another way to write it, if you prefer, y is less than or equal to -1, or y is greater than or equal to 1, which is fine too. It means the same thing. Okie doke. A few more problems. 14 is coming to you here in a second. Okay, let's get this out to focus in on one problem at a time here. Which one of the following lines is an equation of an asymptote of y equals tan x plus pi over 4? Stop the video if you want to think about this a little bit. I'm not going to spend too much time going to the calc here, because you can do that on your own. But really what the question is, and this one it's got a little phase shift going on, is what value, if I put it in here and add it to pi over 4, is going to get me into trouble in tangent? And if you recall, tangent being sine over cosine gets in trouble whenever cosine is 0, which would be happening here and here. And so really the question is, what would cause this to go to pi over 2 would be my first place. And so if I take pi over 4 and I add pi over 4, that's where I would get to pi over 2, but I think maybe that's not what we're looking for here. If I take -3 pi over 4 plus pi over 4, I get to negative, so this is just another place along the way, so I get to negative 2 pi over 4, also known as negative pi over 2. So this is just going the opposite direction. If I go this way, it's pi over 2. If I go negative pi over 2, I also come into trouble. So that would be here in this particular instance. You know what? I'm going to go to my calc because I don't want to confuse you if this sounded confusing. Let me just hit my y equals here, because your calc is also another good place to answer a question like this. Tan x plus pi over 4. And once again, I'm just going to do a zoom trig. And because I'm looking here and I'm seeing, that some of these answers are pi over 4, I'm going to change my window so that my tick marks instead count by pi over 4 instead of pi over 2. So pi over 4. Okay, and remember, depending on your calcs, your TI-83 pluses will sort of actually give you a line that helps you visualize where these asymptotes are. This is TI-84, so I have to visualize them myself. And so looking at the possible answers that I have in this particular case, this is negative pi over 2, this would be negative 3 pi over 4, which would be, in this case, right here. Okay. Moving right along. Yet another beautiful graph to write an equation. What is an equation of this graph? So I would suggest hopefully that you realize that it's either cosec or sec, and you could just use your calculator. But another way you could do this is by, if you want to sort of think about it a little more without a calculator, is realize that this guy does not exist at pi. And so I'm just going to go back to my unit circle because it seems to be a good place for me to think about this. So this thing does not exist at pi, which means that at this point my y value is 0. So the sine of pi is equal to 0. So that means that this is the reciprocal of sine. And 1 over sine theta is equal to cosec theta. So in this case, I'm going to write this, since this is an x-axis, as y equals cosec x. And once again, you could try either one of those on your calc until you find one that matches. Okay, good old inverse functions. Yes, you do need to know. And once again, you could graph these and look at y equals sine inverse x to determine what the range is, but I'm going to go through a different process. If you remember, we take our original y equals sine x and we restrict the domain. And we do that because when we get its inverse, we want it to be a function. And so the restricted domain for sine x, going back to my unit circles, I just want to pick up quadrant 1, my favorite quadrant, and all the other sine values. So sine is positive here, but it's positive over there, so that's why I want to go down here where I get my negative sine values. So I'm going to restrict my domain to negative pi over 2, and the original range then is negative 1 to 1. But this question is saying what's the range of the inverse? And so the range of my inverse is going to be the domain of my original, because this is going to switch positions. So my range then is negative pi over 2 to pi over 2. So, good old inverse functions. Fair game on this test and the Regents. Okay, getting there. Expression arc cos a half is equal to. Remember, arc cos is the same as cos inverse 1/2. Now, this doesn't say whether to do it in degrees or radians, so I'm going to do both. Usually you'll be told. So if you want to put your calc into degrees, it might be more user-friendly. Hit second cos, put a half in, and maybe you know this, but out comes 60 degrees. It would be cool if you did. Radians then would be pi over 3. 180 divided by 3 is equal to 60. But remember, if you ever need to do that, you can always set up a little proportion, where you just write. There's pi radians is 180 degrees, and then you say, okay, I need to figure out what this is for 60. You cross multiply, and next thing you know, you get that. Coming down the home stretch, if you're still with me, to problem number 18. Okay, on the same set of axes, sketch and label the graph of y equals 2 sine x and y equals cos 1/2 x over the domain 0 to 2x. For how many values of x in the interval does 2 sine x equal cos 1/2 x? For what value of x in the interval does 2 sine x plus cos 1/2 x equals 0? I would suggest, I don't want to use up more time on this video, I think, so why don't you, pause the video and you can try this, and I'm going to do a scan and I'll put the solution to this one on my website.